Hello, everyone. Welcome to the startup session. And I hope that you enjoyed the investor session before. I appreciate all of you being here today. And welcome to all our panelists. I think it's going to be an amazing session. First of all, why are we doing this session? Well, what we are trying to do with this event is really bringing the community in Latin America and Spain together and talk about what are the opportunities in all these countries. Can I become an entrepreneur in one of these countries? Because every time we hear about creating a new company in quantum technologies, it sounds like it has to be in the US or in the UK. But we want to know about amazing entrepreneurs, about their journey to become an entrepreneur in quantum technologies. And please, I invite all the audience to use the Q&A on the right-hand side to ask all questions that you might have today. So we are going to start by hearing directly from them, from their journey. So it's a pleasure for me to introduce our first speaker is Carlos Speglich. I hope that was more or less correct. And he worked as Dobslit, and he comes from Brazil. So Carlos, feel free to share your slides, and the floor is yours. Thanks.
Thank you so much. I hope to give you a nice speech, very brief, and please let me know if you are already seeing the slide, please.
Yep.
Okay. Thank you so much. So it's very nice to talk with everyone. My name is Carlos Speglich. I'm here to talk about our Brazilian startup Dobslit. So in this very short period of time that we have, my intention is to address three basic points. Who we are, the backstory of our company. We just have only a few months. Where we are in Brazil, what we are doing, our current work and the future work, and what we believe in. What are the beliefs that lead Dobslit to exist, and the path that we think to pursue in our future. So, basically, who we are, how Dobslit was created. First of all, we have 5 months of life. I think we are the youngest brothers among everyone here in this section. Dobslit was created by 3 people with very different backstories and very different point of views, and that was amazing because everyone brings something different to the table and add value to our company. Basically, the first one, me. I have more than 7 years in multinational corporations creating high-tech products in research and development projects. Basically, I get a project in TRL 1, 2, or 3, and I walk with this project until it reaches TRL 5, 6, 7, 8, perhaps 9, depends on the project, of course. And so basically, my job in Dobslit is to give the company point of view, how to create value in a large company with research and development. With me is Rogério Ruivo. He has a very solid background in classical computing. He has 2 startups besides Dobslit in Brazil. So he adds to the table a very precious insight of how to open, and not only open, but prosper with a startup in the Brazilian environment that is different than others' environments. And Celso Vilas Boas, our master, our mentor, he brings to the table more than 20 years of research in quantum algorithms and quantum information. He leads our internal squads about what are the main topics that must be studied and what's the things that we must do in the research point of view. Like I said, we're in Brazil, but Brazil is kind of big, so let's be more specific. We are in São Paulo. It's the most economic developed state in Brazil. It represents 31% of our GDP. And more specifically, we are in the city of São Carlos. Basically, because me, Celso, and Rogério, we have a very strong tie with UFSCar, the Federal University of São Carlos. But São Carlos does not end with UFSCar. There's also USP that is very strong in physics, mathematics, chemistry. So this leads to an environment unique in São Carlos. In each 100 residents, one have a PhD. So it's the dreamland to do research and development in São Paulo. And we are very close to two major cities in São Paulo, economic areas of Campinas and São Paulo that help us to connect with large companies in Brazil, so we can actually use quantum computing. What we're doing, we have three fronts. Basically, the most applied, we build a user-friendly interface with business variables, because we believe that our customers does not need to know the in-depth quantum computing. I mean, the company has a problem, and we want to offer something that a non-expert can use to solve this problem using quantum computing. We also work very hard to build learning material for business stakeholders, because we believe that people in Brazil must be enlightened of what is quantum computing to make a difference between what's fact and what is fake about quantum computing. There's a lot of misguided information about what we can actually be done with quantum computing. And in the end, we create proof of concepts to show companies that are studying to get in the quantum world that quantum computing can actually bring value today with the technology that's presented today to these customers. So to finish, what we believe here in Brazil, we have a very aggressive economic environment. We are pioneers in quantum computing, but the whole environment is very aggressive with new ideas. So we are not allowed to play with our own thoughts. We must be business driven. We must know what the market wants and deliver it today with what is the hardware can deliver today, and prepare for tomorrow with more qubits, with best quality, less noise. So we have a very strong core for internal research. We believe that we must be ready to deliver value today and tomorrow. Education, like I said, for us, we have a very strong crusade in our work to enlighten people that quantum computing is not scientific fiction for business. It can be applied today. There is sweet points today that can be addressed with quantum computing, but we want that people understand that not all problems can be solved today with quantum computing. So people do not buy fake stories that deliver a project that in 6 months you're going to solve all your problems and everything else. Okay, you might do this in some points, but it's not overall yet. And listen to the market, know the pain points of our customers, and work all the time with them. And in the end, something that is very strong in Dobslit is that it's not only about the readiness of the technology, but the commercial readiness is very important. We must only do our work when the customer is completely with us and say, okay, I'm going to apply it. It can be applied in our business model and it will bring value. We do not do anything that is not pointed to bring value to any kind of model, but to bring value to an actual real world problem. So that's it. I'm very excited to be here, and thank you so much for this opportunity.
Thank you very much, Carlos. That was an interesting journey. And I think the main message from your talk that I will take is how important it is to have this diversity of skills to be able to move forward and create the startup. Very, very interesting. Okay, next is Arturo Silva, and he's from Quantum Works. Arturo, the floor is yours.
Thank you very much, Araceli, and thank you everyone for the invitation. It's an honor to be here from Mexico. We are Quantum Works. I'm going to share my presentation right now. So let's see. So we should probably see the presentation now. Let's see.
Yep, it works.
There. So it works? Thank you. So yeah, we're Quantum Works. I'm the founding partner of the company. We are, personally, I've been interested in quantum computing ever since my undergraduate years. I was first introduced to quantum computing back in 1997 by a professor at my university, at Tec de Monterrey in Mexico, by Hugo Alarcón, who showed me the Shor factoring algorithm, his original paper, and he explained and we discussed, and this was actually the one of my presentations to get a degree to explain the functioning of Shor's algorithm. And ever since then, it was back then it was a purely theoretical work, and it's more than 20 years ago that we've been following the technology from concepts and theories to actual quantum computers. So my journey has been in both academia and the industry, and back in 98, 97, when I first encountered quantum computing through Shor's paper, then following my master's degree at UNAM, and then back at Tec de Monterrey for my PhD under the supervision of Salvador Venegas, Professor Salvador Venegas in Tec de Monterrey in quantum computing. I've been very interested in not only understanding the technology, but applying it to real world problems. So that led to the creation of Quantum Works that we founded back in 2017. We've been operating in the company with the mission of doing quantum computing to solve real world problems. Now that's the first obstacle we encountered, because we have shifted a little bit from doing only quantum computing to actually providing solutions of optimization for our clients. Okay, so we realized that quantum computing can be a very important tool to deliver results to our customers that otherwise would take an enormous amount of time or resources, but it's not a silver bullet. No, as was just mentioned earlier in the previous talk, we don't really have a very one solution for everything. So we established Quantum Works with the mission of doing quantum computing, but now we are providing much more optimization problems. We're located at the center of Mexico. It's 200 kilometers north of Mexico City. It's the red state right on the map, and we can have access to very interesting clients in the region. There are many international companies that we've been able to access and provide solutions for them. So I want to focus on the solutions that we have actually provided and we have charged our customers. They are happy clients for us, and the client hasn't really been interested in quantum computing itself. I mean, we thought at the beginning that it was going to be a very big selling point, but at the moment it really isn't. I mean, it's sort of like a curiosity for them. It's something that they really don't really care that much about. They are interested in having a solution to their problems, and if that takes a quantum computer to solve, then so be it. Use a quantum computer. But if it takes a classical computer or a classical algorithm, so be it also. So some of the partnerships we've established is with IBM. We are currently IBM partners, also with Wolfram Research. We've established a partnership between them. And we've also used some providers and tested the technology from D-Wave Systems, from Microsoft, and from Rigetti. But mainly we've used IBM's Qiskit environment to provide solutions, and D-Waves as well. So what kinds of solutions are these? Well, first of all, the first project we solved using a quantum computer was a career path algorithm. That means that you have some employee in the organization, and he has an interface where he selects his final path, and in this final position, there is trillions of combinations depending on the size of the organizational chart. But there's trillions of combinations from going from one node to the other. And quantum computing actually helped us solve this specific problem of career path for a particular client. And we use this algorithm to provide the solution for this particular customer. Another one is the traveling salesman problem. We currently have a client that needs to optimize the route of their selling points, of their selling trucks, and that has to be in real time. So we also have a quantum algorithm established for them to optimize the path for their trucks to deliver their merchandise. And that's a current solution that is also working through these kind of algorithms. And finally, we also have another client that has to find the optimal point of production using just their production variables. And again, this is a combination of classical and quantum algorithms that provides an optimal point for their parameters of their machines, so that they reduce the waste of their final product. So these are current customers that we have. We are a company based on customers. I mean, we are based on sales. We haven't been out looking for capital because there's a lot of issues finding this capital, and it's very time consuming, and the success rate is, from our experience, really low. So we've dedicated our resources to finding clients and supporting financially our company through sales, not through investment. And these are the solutions that we are currently having. These are some of our clients. Mars, that they make chocolate and pet food. Gas Express Nieto, that sells gas for houses and businesses here in Mexico. They're the biggest providers, at least in the region. And we also established another client with Mondelez. They are a giant of food internationally, and they have trusted us for providing solutions. These are just the three main ones, but we have other customers, other projects that are not necessarily directed to quantum computing, but they are some of our clients right now. So this is basically what I have to say, and I'll be very happy to answer any questions you may have. Thank you very much.
Thank you, Arturo. I was thinking there is a question right now in the question and answer panel for you. So if you don't mind, you can answer directly, and we continue with the other presentation. I think from your presentation, what was really important was, at the beginning, the idea was we are going to do something in quantum computing, but then you become more realistic, and it's how can I actually provide value and a product that customers will pay for, and
That's
you
right.
change your business model. That's a very, very important message. Thank you. Okay,
Thank
we
you.
go next to Enrique Lizaso from Multiverse Computing in Spain. Enrique, the floor is yours.
Yeah, thank you very much, Araceli. I'm very happy to be here. So, yes, I am Enrique Lizaso. I am the CEO of Multiverse Computing. And if you let me, I will share some slides with you and just remark some points in what we have already done in our company. So, let me go here, sharing, and let me put into full screen. Can you see that, please? Can you confirm me?
Yep, all good.
Thank you very much. Well, we are Multiverse Computing. This is a company that deals with applying quantum and quantum-inspired solutions to finance. We have been spotting, as you can see here, in The Economist, also in the Boston Consulting Group, in some reports of IBM and Forbes. In McKinsey, we are part of the Tech Council, the Global Tech Council in quantum computing, that is quite reduced. And we are also inside the Quantum Industry Consortium, which is an association that has this just pushed by the European Union just to associate about more than 100 companies to start working in quantum computing, using the quantum computing and other quantum technologies just for their processes and for their products and so on. In this association, there is a governing board, and we are part of this governing board. So now we are, and this is, I think that this is important also for all the audience to take note. We have a slightly different approach when we start the company and we decide just to run the company and to make it the different steps as fast as we can. Now we have 3 headquarters, 3 offices. The main one is in San Sebastian, Spain. This is where I am currently based, and also during the COVID, the coronavirus crisis. But we have 2 another offices, one in Toronto and the other one in Paris that has been opened last month. Now we are going to open the Munich office during this month or the next month. So this is important for us. So this international scope of the company are helping us because there are some small or large barriers. If you try to rise a quantum company, a super deep tech company inside some countries. So the first thing is, okay, if you want to compete, and this is a competition that is a global competition, then it's better for you just to have a look at what the others are doing and try to move as they move. Okay. So we decide to focus in a particular market. You will see in a few moments that this is the financial, although we are also going to some other associated or quite similar problem markets. You will see. We patent our algorithms. I think that we are going to have about 24 patents at the end of the year that state put us in the same league that the older and slightly larger competitors. And at this moment, we are 19 people. After the round we are running now, and which is quite close to be, or quite near to be closed, we are going to multiply by 2 approximately the number of people in the company. As you can see, 9 of these 19 people are PhD. This is still a deep tech field. So, okay, this is just to show you, this is a report. It's nice if you like the financial world and you like the quantum world. It's nice to have a look at the report from the Boston Consulting Group. We appear here and so on. This is also the Tech Council from McKinsey. You see the usual suspects of the large American companies and so on. And this kind of things is quite difficult to do unless you are on both sides of the Atlantic. So this is our credo. And this credo, our beliefs, has a lot to do with the other speakers has already just shown here. The first point, which is a completely contested point nowadays, is that quantum computing is ready. Yes, it is, just in case you select wisely the problems where you may apply quantum computing. If not, you are going to fail. I will put some examples. As you have already here today, you may use quantum computing for optimization. And if you choose the optimization problems, you can do things that are not possible to do with other computers currently available. For sure, if you just go and take a supercomputer, maybe you can solve some of these problems. But a supercomputer is not possible most of the time to put into the production chain. The situation is, you can imagine yourself, if you are just in the 70s and you just have acquired an Apple One, and you decide that, you remember Apple One, this one that was sold by pieces and you have to mount and so on. So you start your computer and you decide that it will be super nice to have a digital assistant that you talk to the Apple One, and the Apple One say, okay, today is raining. You have to do this tomorrow. Now I can translate you this to French and so on. And even you may think to use this Apple One application and call it Siri. Okay, this is not possible. So the situation nowadays with the quantum computers is the same. I mean, you cannot do some things. You cannot do, for example, in finance, pricing of large, complex derivative instruments and just apply to the real, difficult, not today solvable financial instruments. Is this? Does it mean that the quantum computers are of no use? No. If you cannot do Siri, if you cannot set up Siri, maybe you can start with a spreadsheet. Is a bad business idea? No. On the contrary, a spreadsheet is a super good idea. So the point is, you have to find the spreadsheet for the quantum computer, the killer apps, and so on. On the other side, quantum-inspired computing, which are some specific classical techniques coming from deep physics, are completely available to be used in some particular problems. And remember, if you remember the quantum supremacy announcement by Google, that was later contested by IBM, but still it was remain as a quantum supremacy example. A week later, a group of Chinese just applying tensor networks, a month or 2 months later, and just 64 GPUs, graphic processing units, which is much less than what you need to mine some bitcoins. Okay, they show that they can perform faster and better than the Google quantum computer. So this kind of solution also are available, and it's knowing how to apply them is as useful as knowing how to apply quantum computing. And the other things you have to believe elsewhere. You must deliver these quantum solutions. If you really are working with customers, you have to deliver in a way that you may insert these solutions inside some production lines. And that means that your solution must be production ready. You must to focus on specific solutions. If you try to do a super large approach on, let's say, for example, optimization of Monte Carlo or wherever it goes, you are going to fail. Because maybe you do something which is interesting from an academic, or even some particular business may take some point at that. But the real thing is that most of the fields where you can apply quantum computing are as complex as the physicist itself. In finance, we always say the same. You have Nobel Prizes in physics, you have Nobel Prizes in economy and finance. That should mean something. The field is complex. So you have to focus not in quantum computing for finance, but in quantum computing for specific problems. And the ease of use is paramount. Okay, we decided that we have to start in finance because this is a very good place to start. We think that the banks are deep pocketed. But nowadays, with the crisis and so on, that depends. But so far, we have managed just to have our first million euros in contracts. So it's a place where you can earn your money out if you know what you are doing. So this has been, for sure, we have, for example, places where we apply quantum computing. You may apply in optimization, in quantum machine learning. You have already heard that. You cannot use if you want to apply to real solutions in pricing, or simulation. Simulation is about simulation the whole economy. And then you may have some customers who have more, but you have to focus on large and customers they have. And regarding the technology, so far we are quantum agnostics. You don't know what is going to work at the end. Not only that, for some specific problems, you should use some specific platforms, and for other problems, you may choose some other platforms. If you want to optimize quite well, fast, and so on, maybe you probably are going to use annealers as the wave and so on. We have some papers that compare the performance in particular financial problems of annealers with general gate computers and so on. But you may also use trap ions also, or Rydberg atoms. This is, for example, Pascal. This is, for example, Alpine Quantum Technologies or IonQ. Here is also...
Excuse me, Enrique.
Yes.
If you can wrap up.
Yeah. Thank you very much, Araceli, for reminding me. Okay. As the other ones, we have a number of partners, a partnership, which is also important for us to, and the team, I mean, this is me, maybe a bit younger, and the 4 initial founders, and more of the team that is growing now. And as requested, I am stop sharing my presentation, Araceli, and happy to answer any kind of thing. Thank you.
Thank you, Enrique. So here we see a completely different example, completely different strategy. You have been growing quite fast, which is really amazing to see. You have taken investment and you have been expanding already to several countries. So we have mentioned in the panel before about the Creative Extraction Lab. So there are these opportunities, and it's important to show that they could be successful. Thanks, Enrique. Okay, now we go with Jean-Philippe Bernier, and he's gonna present AnniQ and Spin Quantum Tech. I mentioned both. Jean-Philippe, the floor is yours.
Hi, Araceli. Hi, everyone. Thanks to be here. And well, it's an honor to be here too. Well, let me share my screen. Okay. Can you confirm if you see the screen, please?
Yep.
Okay. Okay, perfect. Thanks. Well, as Araceli told you, is about AnniQ and Spin Quantum Tech. Spin Quantum Tech is our startup company focused on quantum computing, and is a spin-off or born from an artificial intelligence company that is AnniQ. That is a global platform that help business to make better decisions using data. You can find information about us in LinkedIn or by the email if you like. The first thing that I want to share with you is why quantum computing and why Latin America needs to think in quantum computing. And I love so much that phrase about leadership lessons from Steve Jobs is when you are behind, make a leapfrog. And that is very important because quantum computing could be mean for Latin America that kind of leap for new technologies and to take leadership creating technologies and creating more focus on algorithms that could change our economies, our social distribution, and well, our countries in the process. We can create a new industries based on technology and quantum computing. And well, it is glad to see that today there are a lot of companies and startups working in quantum computing around the world, but Latin America has a big opportunity using quantum. So please make a reflection about that and think in quantum for the next big step that we need to start working today. And I very like and agree with my colleagues today that quantum computing is a technology that we have today and we can start creating solutions today for the business, for the market, for the industry. About the spin quantum tech, we have focused on algorithms. I think the first big decision that we made when we create the startup is identify. The focus is about create new hardware, new solutions, and new processing alternatives, or use that alternative that we have in the market today to create new algorithms and solutions based maybe in the software layer using quantum computing. And thinking in that, we decide to work in three main areas because are the areas that we are working in artificial intelligence today with the company AnniQ. So spin quantum tech is the continuity for our business model, extending the artificial intelligence and breaking the barriers with the tran- maybe the actual processing power that we have. We are working in data encryption, creating new data solutions or new encryption algorithms to make more safety, more secure the information. Maybe a lot of people saw information or saw articles that say that quantum computing could break security algorithms in seconds or fractions of seconds. And well, that could be an issue in the near future. For that, we think that create new data encryption algorithms based on quantum computing is a good option for us. Also, extending our current artificial intelligence algorithms using quantum computing. Uh, Speaking about artificial intelligence, the AI has a big challenge today in the processing power. When you need to create a big artificial intelligence solution, maybe a general AI or near to that, and using a lot of data and more and not non-structured data, the processing power that we have today, the traditional processing power, is slow and is not the best solution. And an algorithm or AI solution could take several times to give an answer for that. Using quantum computing, we want to optimize that processing for AI and create new and better algorithms. And here, an important note is not try to convert or transcribe the code of the current AI solutions to quantum. Is about solve the problems in a new ways to get maybe the same or improved answers with our AI based on quantum computing. And molecular simulation is maybe close to artificial intelligence and is about to help industry to create better materials, better solutions, and make more safety or more sustainable in about the environment. Focus on three main areas. We found, and I want to share the information about the campus that we use to maybe create a check and validation every time we faces a challenge with quantum computing to validate if the quantum technologies is the right technology to solve a problem today. First, you need to make a real description and understanding, a deep understanding about the problem, situation, or challenge that you are facing, and think about what is the solution and and the opportunity that you could have making or solving that. And after that, create a parallel between traditional processing alternatives, at least in these four areas, about the resources that you need for to solve that. And sometimes that resources is about the processing power that you need, also about the time that you need to solve that, not only creating the solution, is also getting the answer for the solution in the processing times. About the cost, that I think we need to have focus on the business, and the business always thinks in a cost and comparing the solution. The same using quantum computing. And I like so much my before college that say for every quantum solution, quantum computing solution, you need to choose the right technology, because if you don't that, you could fail in the process. And you need to think in the problem, because if you don't understand and don't have the right process about the problem, you could fail with quantum computing today. After that you have that parallel are match between traditional and quantum computing processing, you could find what is the input data that you have for that, and what kind of data, and the transformation of data. Maybe the most of the quantum computing solutions today is an hybrid between traditional processing or traditional technology plus quantum computing. So you need to think how you need to transform and deliver the data to the quantum system. Finally, think how is that output data, and how do you deliver that or transfer to the rest of the technology to create a complete solution and a complete answer for the business. Also, you need to make a parallel between the value proposition, the benefit, and the differences that you could create with traditional processing between quantum computing. And always in the base, you need to have the business model considered in the process. If you make that, you could have maybe a clear path, or a clear mind about if quantum computing is the right solution to solve a problem today for your company, for your business, for your market in the process. And you need to think that in the business model. Why we do that? Because quantum computing is a nice technology. It sounds very and I say in between quotes is quantum, and so you could think that is a new fashion or mode in the market. But we need to be responsible creating solutions with quantum computing, and it needs at least a deep analysis about if we can create value and solve the solution with better results, not only in the one or series that we deliver for the solution, but if we could create better results for the business, for the market using quantum. Um, Thanks for that. That is maybe the things that I want to share with you with quantum and our journey creating solutions.
Thank you very much, Jean-Philippe. I really like, because you have shown that you diversify both in the technologies that you use to solve the problems and also in the variety of problems that you look at. For example, if we compare with Enrique before, Enrique and they have been kind of focused more on the finance, they have chosen that path, but you have like different kind of potential solutions and also different kind of technologies that you use to actually map depending on the solution, which is quite interesting. Perfect. And our last speaker is also our co-organizer of the event, Rafael Sotelo from Quantum South. Can I ask Enrique and all the other speakers to directly answer the questions and answers in the right panel, because we don't have so much time, I think, for that afterwards. Thank you. Rafael, whenever you are ready.
Thank you. Thank you, Araceli. I am sharing screen right now. I hope it's... Can you confirm?
Perfect.
Okay. So, hello, we are at Quantum South. We develop solutions in the quantum computing area. We work on optimization, applying quantum computing. We were born at Universidad de Montevideo in Uruguay, which we are closely related. And we have been accelerated at IoT Tribe, a UK-based accelerator. That was last year from June to August. We are honored to be one of the organizers of Quantum-Latino and excited for being part of the arousing Latin America quantum community. So we start our journey in 2019 at CES in that year, in January. In Las Vegas, we invited Robert Doredo, an IBM quantum ambassador, to visit Universidad de Montevideo. So in March, he offered a 3-day workshop for students, faculty, and professionals from the industry. We were exposed to IBM Qiskit platform. And once the workshop finished, we considered participating at the Airbus Quantum Computing Challenge. The Airbus Quantum Computing Challenge that year wanted to explore the use of quantum computing in 5 complex aviation problems. They were between the hardest faced by the industry, as said by Airbus. We addressed problem number 5, which was the aircraft loading optimization. The problem asks the best way to select and arrange a number of packages, each one with a given weight and volume in an aircraft. The vehicle has a maximum load capacity and a maximum volume. The objective was to identify the optimal selection of the individual package to be transported that maximize the weight transported in each trip, subject to the load and volume constraints of the given vehicle. Given the exponential increase in the number of possible combinations as the number of packages increases, the problem posed a serious challenge to be solved by classical means. So our solution was inspiring the well-known NAFSA problem, which is NP-complete. We conceived the creation of a Hamiltonian representing the problem. We used the variational quantum eigensolver, VQE, an algorithm present in some quantum computers. Specifically, we use IBM Qiskit platform, libraries, and testing environments. The challenge proposed by Airbus was a success. There were more than 1,000 inscriptions from more than 70 countries. You can see all over the world. 160 teams were actively involved during the challenge. Finally, there were 36 submissions. We can see a close-up of the diversity of regions and organizations that are enrolled in the challenge. This is from the MIT Technology Review. And well, finally, 1 year later, in the 12th of October 2020, the finalists were announced, and we were finally finalists together with teams from the Netherlands and France, from Italy, from Germany, and from China. This is our team. We are the founders of Quantum South. We are a multidisciplinary team, professors of IT, of mathematics, physics, students, and professionals from the industry. So since then, we have been participating in many international regional conferences. This one, for example, is in the first one in Portugal in October 2019 at the International Iberian Nanotechnology Laboratory. A couple of months later, we presented in Chile in the IEEE ChileCon. In 2020, as said, we participated at IoT Tribe, a UK-based accelerator, a UK-based startup accelerator that gave us access to people, access to funding, access to events, either to attend and to present, and give us access to technical and commercial mentors, to pitch training, and help us on the strategy to make a business plan, and especially on the strategy. I want to share that, like Enrique mentioned before, you have to be specific and not with general solutions, but a specific one. So we work, we share the same vision. We work with complex optimization problems for cargo in airlines and ships, leveraging quantum computing. So with the same restriction, same limited time, software optimization through best practice and extended space linear programming. So the goal here is to achieve better results than conventional solutions available today and help companies to improve revenues and reduce costs. So we are addressing airline cargo sector, then maritime cargo, and we are also having a line of work in financial services. So to be more specific, this is the business opportunity we found this is some figures about the worldwide air cargo traffic market. As you see, is billionaire in revenues, and it's difficult to see here. This is from official sources, from IATA and from Boeing. The cargo load factor is this is average 50%, while passenger load factor was 81% in 2017. So we find here room to help companies to improve these numbers. So how is it being done today? A lot of restriction, limited time, software optimization through best practices, and limited space programming. So our solution is a software product that will integrate to legacy systems that is based on cargo to be dispatched in an aircraft or ship with limited capacity will provide the best allocation based on cost and revenue. And the core optimization algorithms are based on quantum computing technology. This is the architecture of our product. We need to integrate with legacy systems, then prepare the data for each specific run of the algorithm, apply it to a particular instance of the problem, and finally send it to the quantum computer to run the algorithm based on VQE to obtain the best solutions. This is our timeline for the next years. We are developing the product and offering consultancy. We plan to make a proof of concepts and pilots. 3 years from now, once quantum capacity is available by providers, we will be delivering product either by software licensing or as software as a service. So we are very integrated to the global ecosystem through participation in many publications, in many conferences, in many events, both as speakers and attendees, and now as organizers, also here at Quantum-Latino. And last year, we also participated in Slingshot, and where we could reach DHL, Lufthansa Cargo, Singapore Airlines, and so on. So we are pushing the air cargo companies, and we are getting great contacts there. So we also have our integration involves obviously manufacturers. We work with platforms from IBM, AWS, T-Wave, Cambridge Quantum Computing, Microsoft. We have an agreement with Quantum Brilliance. We are working in collaboration. This is from Australia. We are working in collaboration with them at POSI Supercomputing Center, the Quantum Pioneers POSI program. And we are in contact with other major vendors like AnniQ, Honeywell, Fujitsu, Google, and Atos. So this is, as said, with a special agreement with manufacturer Quantum Brilliance from Australia. And a couple of months ago, we participated in an event where we are part of the Quantum Pioneers, together, participants from industry, together with participants from academia. So we are also part of Microsoft Quantum Network. As a matter of fact, the University of Montevideo is part of the Microsoft Quantum Network that give us access together with only 20 universities, and we are the only one in Latin America. Hope that more colleagues can join. That gave us access to a curricula. Last semester, we delivered a course on quantum computing for undergraduates and for graduate students. And this is the happy faces at the end of the last classes, happy faces of students and professors. And well, this is just a bonus track. This is from QURECA, just to be aware that this worldwide map is public investment, public funds for quantum effort worldwide. As you see, Latin America is gray. There is known reported funding for developing this future quantum community. So we hope this will change. So to end, this is Quantum South completed a seed round provided by funding, provided by the founder itself, by family and friends, but the AnniQ, which is the Uruguayan National Agency for Research and Innovation. As for Quantum South and Universidad de Montevideo, we are committed to build a vibrant quantum community in Latin America. We have postdoc opportunities open right now, and research opportunities available for graduate students. We offer internships for graduate and undergraduate students, and we are open to collaboration with academia, industry, and investors. So you can contact me if you are interested, especially in postdoc opportunities that have a close deadline. Please contact me to Sotelo@quantumsouth.com. Well, finally, We are open to collaboration with major industries worldwide, in Latin America, in Uruguay, and in the rest of the world. So to help them be quantum computing ready. We are looking for big complex problems that may bring the quantum advantage to industry and government sectors. So that's all for Quantum South. Thank you very much, Araceli and colleagues.
Thank you, Rafael. I always like to hear the story of Quantum South with the Airbus Computing Challenge, and I think it's a good example of collaborations, how you have built the company on collaborations, academics and industry around the world. So this is a very nice example of that. We don't have much time. I'm going to ask you something, and you have exactly 1 minute, each of you, to answer. But before that, I want a remark. If you have a look around in all our speakers, we are focusing on the software side. And this is important to notice because as we heard in the investors panel before, they said that they love the science. They always like to look at things that they can scale really quickly and in a way that you can promise a lot of return, of course. And sometimes that is a challenge with software, you know that. So I think this is a message for the investors that are out there. Here you have fantastic science, fantastic ideas. They are focusing on software, but I think here is an opportunity for you as well in how you can develop quantum computing solutions or quantum technology solutions for different kind of sectors, business sectors, industries, and problems. And there is an opportunity in Latin America and in Spain. So please open up to these opportunities. This is my message to the investors. So the question before we wrap up, how would you summarize the entrepreneurship opportunities in your country? And what do you think is missing? So if there are out there any academics in your country that want to do the same that you are doing, and you know that is quite hard because there are a lot of people, how can I be an entrepreneur? We don't have we are not US where we have investors putting millions. What is your advice to all those people out there? So you have exactly 1 minute. Okay, Rafael, you can start.
Araceli, just I have been talking, so I am warm. Half a minute.
Go.
So for Uruguay, and I think for Latin America, there is something. Last week we have had an important news that has been maybe a hope for all of us. The first unicorn from Uruguay quoted has been offered in Wall Street, in Nasdaq. So it raised. It was valued in more than $7 billion US. So it was incredible news for a Uruguayan startup founded 5 years ago. So they are in another sector, but that gives hope for all of us. So that is my message is, well, we should look to the people which are successful and try to imitate and try to change the reality of our region.
Thank you, Rafael. Jean-Philippe?
Well, thanks. I think the process or that we need is more adoption of the technology, at least in Colombia. We need that the industry, that academia makes a join in the process and maybe short the bridge of the process to access new technologies and thinking in quantum and create solutions and open the opportunities to test that kind of solutions. The entrepreneur system or ecosystem in Colombia is growing very fast. We have a lot of companies in other technologies making huge stages in Colombia and in the global market. So I think it is the right time for quantum to make that step in Colombia.
Perfect. That's wonderful to hear. Enrique?
Well, in fact, the recommendation is go abroad as fast as you can. I mean, don't hesitate of doing that. We do that and it's fine. I mean, and if you really want to fight with the other guys and to play in the same place that the bigger guys are playing, you have to go for the you have to echarle un par and just fight. We are not not worse than them. But the point is, financing, funding the operation, going these rounds and so on, oblige you to be and to have visibility on the international arena. So if we remain in a super close part of the world, okay, this is just playing card games. I mean, it's very difficult to win in that game. If not, I mean, we are even the same or better than some other players. So you have to believe that and do what the other guys are doing there.
Agree on that you can be much better than some other players. Arturo?
Thank you, Araceli. I think we need to broaden the horizons of academia. We are very used to having just a focus on academic work, which is fine, but there's a lot of opportunities outside academia that really solve real-world problems and contribute to society. So broadening the spectrum of work for current academia participants to entrepreneurship and to the private sector, and not just in the university, is something that would enrich the environment and would create opportunities and reach a very deep pool of talent that we have, and we can tap into it and offer solutions much broadly than the academic current status quo.
I agree with that as well. Thanks, Arturo. And to end, Carlos?
Thank you. Well, first of all, I believe that in South America, I want to speak for Brazil, but I think almost the same apply to other countries. We do have a lot of opportunities here. I agree with my colleagues. Thinking about other countries is good, is healthy, and it's good. But I think there is a lot of things that can be extracted in South America, in Brazil, in Colombia, in whatever country you may be hearing this. In São Carlos, the city that we have our main office, I think 2 or 3 unicorns were born in this city. In Campinas, is 100 something kilometers away. It's 5 to 6 unicorns were born in the last years. So there is, yes, opportunity. We're not in the United States. You have funding flowing through different kind of ways, but there is large companies with real problems that can be solved. Again, can be solved today and tomorrow with quantum computing. So what we are doing is reaching to these companies and building small to not so small to medium projects to found ourselves with this money. Okay, so I believe, once again, to finish, I think there is a lot of opportunities in Brazil, and I believe in whole South America. And just to finish, I think this is the main problem for us. I don't know if my colleagues feel the same. We need a very specialized labor, people that can actually do quantum computing. And there's not so much people in the market for this. And at least in Brazil, I don't know other countries, there's a lot of prejudice against companies in the university. It's like companies come and steal knowledge, they are bad people, bad capitalism, and all this kind of thing. So one thing that we are fighting against here is to showing, okay, it's good for university to have a healthy relationship with industry, with startups, with companies. And that is a scenario that we are feeling that is changing. But our main problem is to convince students, to convince young professors that, okay, you may continue doing research, but it's not only university. You can do research in a company. And that's when we do this, I think looking for funding will be a minor problem. My belief.
Thank you, Carlos. Yeah, it's the mindset. It's, as I always said, it's the gap between the researcher mindset, the fundamental scientist and the one who wants to become an entrepreneur. Thank you very much, everyone. I know that we are way over time, but it was really, really interesting. So thanks for all your talks, for sharing your journey with us. And I invite all of you to our next talk now with quantum computing. Thank you. Have a good day and enjoy the event.
Thanks
Bye-bye.
to you.
Okay. Thank you very much.